Welcome everybody to this lecture in macroeconomics where we talk about money and financial markets. This is the structure of our outline, the structure of our course, and these are the learning objectives. Like after you've worked through this chapter, you should know the factors which influence money demand, and you should be able to explain how shocks of the demand side of money or the supply side of money influence the equilibrium level of the interest rate. You should also be able to talk about the relationship between the bond price and the bond yield, which is the interest rate. You should be able to explain how central banks use open market operations in order to influence money supply. You should know the role of commercial banks in the transmission mechanism, and you should also be able to derive the money multiplier in a simple economic setting. Let's start with the demand for money. Money is needed to complete transactions, and we assume that the higher the number or the volume of transactions, the higher the demand for money. So in case that GDP increases, this will have a positive effect on money demand. Furthermore, we assume that bonds have a fixed coupon and yield the interest rate I, and the higher the interest rate is, the higher the opportunity cost of holding money. So the higher the interest rate, the lower the demand for money. This is considered in our money demand function. First of all, we have one term which depends positively on the GDP level. In case that GDP increases, then money demand increases. It is also considered that there is a negative relationship between money demand and the interest rate. In case that the interest rate increases, the opportunity cost of holding money increases, and therefore money demand will be lower. And this is modeled by including like this minus sign in front of the interest rate expression. Let's be a little bit more precise and let's have a look at the different components of this equation 1. So we have here a function for nominal money demand, and this is a function of the variables and parameters on the right-hand side of this equation. The domestic price level, D0 and Y, are treated as exogenous variables here in this chapter. So P represents the commodity price, the price for goods. D0 is the autonomous component of money demand, and Y is the income variable or our GDP variable. The endogenous variable in this chapter is I, the interest rate, and then we have two parameters, D1 and D2. D1 is the income responsiveness of the demand for money, and D2 is the interest rate responsiveness of the demand for money. When you look into this equation, once more, it is the case that these two parameters, they link one variable with the function. So D1 links GDP to money demand, and D2 relates the interest rate to the money demand function. So D1 tells us by how much money demand increases in case that GDP is up, and D2 tells us by how much money demand is down in case that the interest rate is up. Then we have one component D0 here. This is the autonomous component. So for example, money demand could also depend on wealth, but we are not interested in this relationship, and therefore we are condensing a lot of information into this autonomous component. For example, if wealth is up, money demand should increase, and hence we can increase the autonomous component. The terms in brackets are real variables, so we have to multiply through by the price by the term in brackets are real variables, so we have to multiply through by the goods price in order to receive nominal money demand. Let's come up with a numerical example. We are assuming that the goods prices are normalized to 1. The autonomous component of money demand is equal to 1,000. The GDP level is equal to 2,000. D1 is equal to 1. And D2 is equal to 100. When we plug in the numbers in our money demand relationship, then we get to this expression here, that money demand is equal to 3,000 minus 100i. We want to draw the money demand function in a diagram where the interest rate is on the vertical axis and money demand on the horizontal axis. Let's have a look. This is the diagram I'm talking about. We want to draw this money demand function in one interest rate money demand relationship, interest rate on the vertical axis, money demand on the horizontal axis. This is once more the relationship for money demand in our numerical example. In the first step, I would like to know, where does this curve intersect with the horizontal axis? In order to find out, we need to answer the following question. Which value does the demand for money take in case that the interest rate is equal to 0? So we have to set the 0 here in this equation, and then we get to know that money demand will be equal to 3,000. In order to find out the intersection of the money demand curve with the vertical axis, we have to answer the question, at which interest rate level is the demand for money equal to 0? So we have to set this relationship equal to 0 and solve for the interest rate. So the left-hand side equal to 0. When we solve for the interest rate, we get the information here that the interest rate has to be equal to 0. When the interest rate is equal to 0, then money demand is equal to 0. And hence, this is displayed in this graph. So the intersection with the vertical axis takes place at the interest rate of 30%. So when the interest rate is 30%, the demand for money would be equal to 0. And what happens if the interest rate is 0? Then money demand would be equal to 3,000. We have found 2 points for our money demand relationship. When we combine these 2 points, these 2 extreme points, then we get the money demand function. So we were able to derive our first characteristic of this money demand relationship. The money demand curve has a negative slope in this interest rate money demand diagram. A second characteristic is that we think about what kind of events are shifting the money demand relationship to the right or to the left. This is clarified on the next slide, where we talk about the shifts of the money demand curve. A general definition is that an equilibrium curve shifts if one variable changes, which is included in the function, but is not displayed on one of the 2 axes. Hence, our money demand curve will shift to the right. Money demand will increase in case that the price level increases, in case that the income increases, or in case that the autonomous component of money demand increases. Until now, we have focused on nominal money demand. Let's focus on nominal money supply. In this section, we are assuming that the private households only hold coins and notes. They only hold cash as money, and there are no checkable deposits. Therefore, the commercial banking sector does not play a role in this part. The central bank provides households with cash, So the central bank provides money. The money supply is equal to the cash provided by the central bank. In our numerical example, we will assume that money supply is equal to 2,000. How does the equilibrium condition look like? The equilibrium condition, once more, is that money supply has to be equal to money demand. So money supply, the left-hand side, has to be equal to money demand. In our graph, it has to be the case that we have to look for the intersection of the money demand relationship and the money supply relationship. So where the two curves intersect, the equilibrium condition is fulfilled, and hence the equilibrium interest rate is equal to 10%. What happens if income decreases? Here we are assuming that income decreases by 500 units. So the money demand relationship shifts to the left. We get a new intersection here in this green point. So it's the case that a decrease of GDP leads to a decrease in money demand, and therefore the interest rate decreases from 10 to 5. On the next slide, I would like to analyze what happens if money supply decreases. Here we are assuming that the change in money supply is equal to a negative 500, so that the new level of money supply is equal to 1,500. The money supply curve shifts to the left, and therefore the interest rate increases from 10 to 15. Hence, we have analyzed two changes of data. Here, we were looking at what happens if the central bank decreases money supply. This is a contractionary monetary policy and leads to an increase of the interest rate. In the previous slide, we were looking at what happens if the GDP decreases. This is a money demand shock. Money demand decreases, which leads to a decrease of the interest rate. I would like to give you some time to digest what you have learned so far. Let's make a short break here and see you again in the next video. Thank you very much. Have a nice day. Bye bye.